Alright, so this is the second class and we're going to discuss about transducers. So I want everybody to pay attention. This is a class. The students that are present right now, we know that others might still be joining us. But before then, the start is going to start. We are not going to wait for them. So we are going to start with a discussion about transducers. So if you are there, you know, as electrical engineering students, that term transducer is not new to you. Am I right? It is not new. But we are going to go into other dimensions of transducer that you might not have learned before. We are going to new dimensions, new explanations about it. Are we there? All right. So the course remains electronic instrumentation. And the topic we are discussing in the first chapter, we have started last week. We are going to talk more this week about the course, and we are going straight away to the subject for today, which is transducer. We are going to do an introduction to transducers and sensors. A useful way to classify transducer is on the basis of the property that the device is intended to measure. We can define a transducer as a device that converts a primary form of energy to a corresponding signal with a different energy form. That's a new definition, isn't it? A device that converts energy, from a primary form to another form of energy, the corresponding form. That is a transducer. Another way, we can also define transducer in another way, that it's a device that takes a form of a sensor and an actuator. So take note of the terms. Sensor, actuator. So we are saying the two of them, we can actually refer to them or use them interchangeably with the term transducer. The concept of transducer is very important in engineering, especially at industrial work environments. The concept of transducer is very important. Now we talk about primary energy form. In the first definition, convert energy from primary form to energy in another form. Is that not so? So we are talking about primary energy form. What do we mean by primary energy form? Energy exists in various forms. The sun that is shining outside is a form of energy, like you know, isn't it? As I'm speaking, it's a form of energy that is coming out. Is that not so? Yes, sir. Yes. And you will note also that most of this energy can be converted into other various forms of energy, which might be electrical energy, if you wish to. Alright? So I want to mention some of forms of energy that we are going to deal with, or we are going to explain about, or talk about, that you can encounter at industrial environments. So let's start. Primary forms of energy can be mechanical, thermal, electromagnetic, optical, chemical, and so on and so forth. Alright? Now, let us now see what is a sensor. We said a sensor or actuator, either of them can actually be a transducer. That is, a transducer can take either of this form. What is a sensor? A sensor is a device that detects or measures a signal or stimulus, or that acquires information from the real world. The real world. What do we mean by real world? We mean the things that happen in our environment, which comprises of energy in various forms: pressure, force, displacement, acceleration, sunlight energy, and so on and so forth. That is what we mean by the real world. So a sensor is a device that takes in that energy, and converts it into another form. Alright, you will see that actually is a transducer. But in this case, it's referred to as a sensor. A sensor, like we said, is a device that detects or measures a signal or stimulus, or that acquires information from the real world. We have defined what the real world actually means. That is, things that happen in the environment. Many forms of energy exist in our environment. And then we are giving several examples of such. Now let's look at an example. An example of a sensor is a thermometer. Everybody knows what a thermometer does, isn't it?
Yes, sir.
What does it do?
It measures the temperature.
Measures temperature. That is the hotness, the degree of hotness or coldness of a body. So in that case, if you use the thermometer in that manner, thermometer is actually a sensor. It's a sensor. Now what about actuator? Actuator is a device that generates a signal or stimulus. A device that generates a signal or stimulus. And we have an example. An example is a heater. An example is what? Heater. 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 Alright. Now, we want to talk about the basic instrument system. The basic instrument system has three components. Alright? And we can represent this instrument system with simple block diagram like this. A simple block diagram like this. Okay? So we have the input, which is actually a variable from the real world. It could be force, it could be pressure, it could be heat coming in. So that's the first part that comes into the sensing element of the instrument system. Alright? So we have the sensor here. And as you know, this sensor is nothing but what? It's a transducer. It's a transducer. Now the sensor collects information from the inputs and then direct that information to the processor. The instrument system has a processor within it. And then the processor sends whatever is received, processes it, and gives the output device, which is actually a receiver, the signal, the receiver. Then you have the output signal going. Output signal going, okay? Output. That is the basic instrument system. That is the basic instrument system. Alright? Now, you will see that we have only 3 blocks here. It's a little bit different from the control system block diagram that we treated last time. There we have the process, what is actually happening in the industry, called process. And then we have a signal that goes around from the process back to the process as a kind of feedback. Here we are just talking about the instrument system alone. These 3 blocks can be used to represent that. Alright? Now, let's talk a little bit about transducer. We said transducer can convert energy from one form to the other. Now, in nature, there are so many variables that are in form of energy that change from one form to another. And as an electrical engineer or engineering student, you must be aware that these various forms of energy, all of them, various forms of energy can be converted into electrical energy. Think of any type of energy in the real world. Is it motion? Is it temperature? Is it pressure? Is it stress, strain, force, speech? Whatever. Think of any type of energy. Any quantity that is variable, that is not just one value, can be converted into electrical energy. And before you can achieve that, what happens is that you will need a transducer. You need a transducer. So science has become so advanced that all these various sources of energy have been, examined, and a transducer has been developed for each one of them. At least a transducer has been developed for each one of the energies that you can imagine. Any form of energy that you can imagine, a transducer has been developed for them. Yes, that is how it is. So that is why transducer is very important. Now, the scientific statement that energy can neither be created nor destroyed, but can be converted from one form to another. That is how it is. So energy exists in abundance in nature, but to manipulate or use energies to achieve something, it may require that you take them from one form to another. So it is important to learn about transducers in order to do that, to convert energy from one form to another. All right. Now let me ask you this question. In your previous knowledge, I want to ask you, what transducer is required to convert its energy to electrical energy? Mention one. Number one, thermocouple. Nobody should forget that. Thermocouple, number one. Another one. He said? Thermostat. Thermistor. Thermostat is not correct. It does not convert heat to electrical energy. It does something else. Somebody said thermistor, isn't it? Thermistor is another one. It converts heat energy into electrical energy. Yes, thermistor does that. Thermistor does that. Now in this course, you are going to learn about this and another one that you have not heard about before, because you are going to go there very soon. Let me ask you another one. What transducer will you need to convert force into electrical energy? Force. Okay. Somebody said what? Strain gauge. Wow. That's fine. EEI 311 is working, isn't it? It's working. That's fine. That's fine. We also have load cell. That's right. You're right. You're right. The two of them can convert force or pressure into electrical energy. Okay? Right. Now, as instrumentation engineers, you will deal with this, which is actually this, so much at the industry. You will deal with sensors, actuators. You deal with them extensively. So that is why in this course we are going to help you to understand that you must know the principle of operation and application of those devices before you can effectively utilize them. I think you get it. Yes, that is why this course is building upon your previous knowledge in EEI 311, EEI 411. Remember you took 411 last semester. Is that not so?
Yes, sir.
Yes. So this is building upon that. You are going to learn new devices that you have not learned about before. But I want you to understand basically the way the control system, instrumentation system works. Basically, the block diagram that we used last time is the way they work. Why this one is for the instrument system. The instrument system and the control system. So the first part that you will be learning is here. You'll be learning much more about it. In fact, you have been learning about it from time. Sensors, because you have always been dealing with different types of sensors. Maybe you are talking about a diaphragm. What does it do? Converts displacement pressure into electrical signal. It's a transducer. Somebody said? Bodon tube. It's a transducer. All of them, they convert energy from one form to another. You have been dealing with the basic portion of the instrumentation system, the opening portion, which is very, very crucial. If you cannot get this place right, then all the other things in the control system will not work. You must get the opening right, which is the inputs coming in through a sensor. If you can capture it correctly, then you'll be able to manipulate and control it. Is that also? You remember in the last class we said if you cannot measure something, we cannot control it. Did you remember that statement? Yes. And the measurement will take place at these points from the sensor. So the sensor is quite important. It's critical in the instrumentation system. If you can't get the measurements, then you cannot do any control. So it's very important. So let's have that in mind. Now, let's briefly also mention some of the physical variables that we do measure in electrical instrumentation and control system. Now, especially when it comes to industrial environment, we have various parameters that are measured. Some of them we have mentioned today. We are still going to mention others now. So we have quantities such as temperature, pressure, speed, flow rates, force, movement, velocity, acceleration, stress, strain. All right? We are talking about temperature, pressure, speed. Okay? We are talking about flow rates. We are talking about force, movement, velocity. Okay? Acceleration. We are talking about stress and strain. Stress and strain. We are talking about level or depth. Level or depth. Remember level measurements? We are talking about mass or weight. Mass or weight. Density. We're talking about size or volume. We're talking about acidity or alkalinity. What is acidity or alkalinity? Alkalinity. What's that? What's that? pH. It's a quantity that's also measured in the industry. You know the reason why that is important? Most of the industrial products are produced from chemicals, and the chemical must be right before you get the correct product. So there's need to do measurement of pH of many quantities, many substances, right? And so there's a transducer that will detect that. There's a transducer that detects that. Okay. Now, measuring physical quantities require sensors, like we have said. Require sensors. And then the sensors may be simple thing. Maybe just a switch. A switch. For instance, on and off switch can be the sensor that gets an information from somewhere. For example, you want to measure an object, that there's a particular object moving here, you can use a proximity switch. You can use what? Proximity switch. Have you heard about that before?
Yes.
Proximity switch. To detect an object. You want to measure the level or depth of a storage tank, for instance. You can use, for example, level sensor or level switch. It's called level sensor or level switch. In your previous study also, we have learned about level measurements. We talk about capacitive transducer that measure level, float transducer, and so on and so forth. You remember those ones?
Yes.
Yes. They are the basic instrumentations, basic parts of sensors. Now you want to measure hotness or coldness of a body, you can use the thermostat. You know a thermostat can actually be a switch. It's actually a switch. It's a switch. Converts that heat energy into mechanical energy kind of. Alright. Then to measure pressure, whether high or low, we can use a pressure switch. So all these switch that we mentioned, they are actually input transducers or sensors. Sensors. Can be regarded as sensors. Alright? So a transducer is usually designed to measure a specific measurement. To measure what? Specific measurement. And the term measurement is not new, right? You know what we mean by measurement? That is input variable that we are trying to capture. That is the measure. Alright? Now, to actually set up an instrumentation system, a very good knowledge of the electrical characteristics, mechanical characteristics of a transducer is quite important. Are you there? Knowledge of both electrical and mechanical characteristics of a transducer is very important. That is what is going to help you to choose a particular transducer for specific application. That's what I said earlier. In an industrial environment, you will come across many of these transducers working as sensors. So if you don't understand their operation, properties, electrical properties, mechanical properties, you will not be able to choose correctly or deal with them efficiently. Alright. So it is necessary many times to get the characteristics or properties of these devices. Now, there are certain requirements that are needed in order to choose a good, transducer for instrumentation system. And we're going to talk about some of these properties right now. So right now we are going to talk about properties of the transducers. Alright? So we're talking about properties. Properties that are of interest in choosing a transducer. 1. Ruggedness. First one, ruggedness. Linearity. Linearity. Next one, repeatability. Repeatability. Then convenience. That's convenience. Convenient instrumentation. Convenient instrumentation. High stability and reliability. High stability and reliability. A very good dynamic response. Good dynamic response. Good dynamic response and excellent mechanical characteristics. Excellent mechanical characteristics. Okay. So these are properties that are desirable in a transducer. Properties that are desirable in a transducer. Now, the first one here is ruggedness. What does it involve? Ability of that transducer to actually withstand overloads. Alright? With safety stops for overload protection. When you have that, you have a rugged system. It's not that when it is slightly overloaded, then it breaks. You understand? If it cannot be overloaded at all, it means it's not rugged. And that will not be fine. it must be, capable of withstanding overload. Exactly. That's what we mean by ruggedness. For linearity, ability to reproduce input-output characteristics symmetrically and linearly. Alright? And the overall linearity is an important factor that is considered. Linearity, to produce input-output. Input increasing, output increasing. What happens? Along the line. Linearity is very important. The next one is repeatability. To use the device over and over and get the same result when it's being subjected to the same input in the same environment. It's not that when you take it to work now and then you repeat a few days time the same or similar environment and then it's giving different kind of results. That's what we're talking about, repeatability. For repeatability, the device has to be able to repeat the measurements over and over again with the same results, quite similar results. Are you there? Alright? But that means the measurement environment is actually similar. Otherwise, you cannot expect the device to respond equally to different inputs at different environments. The measurement environment has to be the same. Alright? Convenient instrumentation. Your instrument system is capable of providing sufficiently high analog signal. With high signal to noise ratio. The signal is what you need. When you take a sensor to detect a variable, it's converting it to another energy. That energy is high enough to actually that you can use it in another circuit to do something else. Or perhaps you will need to actually raise the signal up by means of an amplifier and things like that. So you must consider that. And that's what we mean under convenient instrumentation. You must be able to generate a high, analog output signal with high signal to noise ratio. Also, many times digital outputs are preferred. In most cases, digital outputs are preferred. So you will soon see, when we are dealing with these devices, you will see few ones that can actually produce a digital output. That will give you digital output directly. For instance, what kind of output do you expect from a thermocouple? A thermocouple, is it digital or analog? Purely analog. It just produce EMF, analog signal. But sometimes when you are dealing with instrumentation system, you actually require a digital output in your control system. So you consider that one also as an important property to actually select a particular transducer you are going to use. And there are some that normally give digital output. Alright. The next one, high stability and reliability. That is, we want minimum error in the measurements. Is that also? Minimum error. That is when we can talk about stability and reliability. Unaffected by probably temperature, vibrations, and the environmental variations. But when your device is, being affected by these environmental variations, that means it's going to give wrong results, which is not reliable. So we require a stable and reliable system. It's another important property of transducers. It's another important property of transducers. Good dynamic response. A device that can give you faithful output, with respect to input. Output is faithful to input when taken as a function of time. That is what we mean by dynamic response. Faithful output with respect to input. That is, when the input is varying, how does the output behave? Is it faithfully following the changes at the input? When you have that, then you have very good dynamic response. When you have that, you have very good dynamic response. And this is taken as a function of time. Then we can also check the frequency response of the device. Very good frequency response is also a desirable property. The last point here, we talk about excellent mechanical characteristics. Excellent mechanical characteristics. Mechanical characteristics can also affect the performance of your transducer. And so, it can affect the performance in static, quasi-static, and dynamic states. Static, what does static means? That is stable, no, stable. Then we have quasi-static, not really stable, can move and come back. Then dynamic means the thing is on the, on the variable, motion, kind of. So we have those characteristics. You should know these characteristics and be able to briefly explain what they involve when it comes to selecting a transducer. Are we there? Good. Alright. So that is that about the introduction to transducers. We've come to the end. Now, if you haven't subscribed to this channel, remember to hit the subscribe button and then click the thumb up, like the video and share. Alright? So, we expect to see you in the next video. Bye bye.